for is this is basically the anti-product rule, in a sense, okay? The best thing about this is it can be used to integrate functions with asymptotes, or integrate, I'm going to call them non-integrable or non-integratable functions. Okay. So for a really good example of this is ln x. So ln x is very difficult to integrate without this. It's easy to differentiate, but not so much to integrate. And in terms of difficulty of integrating, there is a sort of, I guess, a mnemonic kind of for how to remember it, and that is Liate. So Liate. And these go in sort of order of hardest to integrate to easiest. So if you've got a product of two of these, then we would rather not integrate logarithms. If we don't have logarithms, we'd rather not integrate inverse trig functions. We'd rather then not integrate algebraic functions, which is like x squared. Then we'd rather not integrate trig functions. And then we'd, to be honest, we'd be quite happy to integrate an exponential. Okay. So because these are hardest to integrate, the top also tells us what we prefer to differentiate. Okay, so in any question, identify the function highest up the list. Now, the function that's highest up the list, we are going to call this u. And the reason we're going to do this is because u gets differentiated. Okay, so the idea is we're going to differentiate u and try and change it into another integral that finds the same thing. So just like substitution, we're taking a side path for a direct path, which is pretty difficult. Okay, in this case, the blockage on our road to integrating is a function that does not integrate. A simple y equals ln x, or let's say y dash equals ln x. And I know that at x equals 0, y equals 1. So this is just a new skill for integrating. So we've now got the integral of ln x dx. So I want to make dx the, so I want to make ln x u. Okay, so looking at this, ln x is my u, and then I've got some dv by dx. Now this can sometimes be a little tricky to see. And the reason I'm going to a natural log is because you can use a trick. If there's something you don't like integrating, do 1 times it, because now we can differentiate the logarithm and treat 1 as something we want to integrate. Okay. Now, for setting this up, I go back to my grid. Okay, I like grids. We're going to set up in the same way where the functions u and v are on the top and their derivatives are on the bottom. So u equals ln x and dv by dx equals 1. Now, instead of differentiating both, remember if I go down, I differentiate. So u dash equals 1 over x. But if I go up, I have to integrate. So v is equal to x. But now again, I plug it into the formula. So the integral of natural log of x is equal to u times v. So we're going to do, didn't mean to do that, sorry. U times v, so that's going to be x ln x minus the integral of v du by dx, or vu dash. So minus the integral of v times u dash dx. So let's keep that red just for continuity. So that's going to equal x ln x, subtract, well, this is the integral of 1, which is going to be x. Okay, so notice we now have a product. Okay, so this is why sometimes people call it the anti-product rule. And just because we've used the product rule or the anti-product rule or integration by parts or whatever you want to call it, because it's indefinite, we have plus c. So this is always if we have no limits. Let's change this value of x to 1. And we can find c the same way. At x equals 1, y equals 1. So this becomes 1 equals 1 ln 1 minus 1 plus c. Well, ln of 1 is 0, so c equals 2. So we can say, finally, y equals x ln x minus x plus 2. Okay, so to summarize the method, 1, label the highest Liate function, and highest means sort of earliest in the name Liate, as u, and the other function as v dash. 2, differentiate u and integrate v dash. When we integrate v dash, we do it definitely. We don't have a plus c. 3, use the equation uv minus the integral of vu dash. Okay. Now, if we have limits, so if there are limits, everything goes in the limit. Okay. So for example, if we had limits for our y equation, instead of being given a point to find c, we would have to put x ln x minus x all in the same limits. Okay. Now, just before we look at practicing this in some questions, there is a special couple of cases. For example, if I'd have had, let's say the integral of x squared sine x dx. So here's our clue that we're going to be using the parts because we've got a product, no composite function. What you would do is, looking at our list, we can see that u will equal x and v dash equals sine. So then x squared, u dash equals 2x and v equals minus cosine x. We do all of our integrating, that's all good. So we get uv, so x squared times minus cos x, subtract the integral of vu dash. That's going to be minus cos x, so it makes that plus 2x cos x dx. Now this, again, we need to integrate by parts. And as before, we keep the same, this is still algebraic, it's highest up our list, so this is u and this is v dash again. Okay? Special case 2, and this one is a favorite of theirs. The integral of e to the x sine x dx. Now, if you ever see an exponential and a trig combined, we start by writing that the value of this answer is what we call I. It's what we call the integral. Okay, so the integral, the number of this is I. Using our Liate, we can see that u, well, let's put a box around this one. So here, u is equal to our trig function, because that comes before exponential. So u is sine x, v dash is equal to e to the x. The reason we do that is because, well, v dash is really easy to integrate, and u dash is easy to differentiate. I guess slightly harder than an exponential because it does actually change. Okay, so when we put this equation in, we now have that the integral I is equal to uv e to the x sine x subtract the integral of e to the x cos x. Okay, now again, we're going to do the same by parts integration. Here, we know that u is now cos x. So that's going to become minus sine x. So plugging it all in, be careful with your signs here. So we get e to the x sine x. Subtract, now uv here is e to the x cos x, minus the integral of v u dash, e to the x times minus sine x dx. So we get e to the x sine x minus e to the x cos x plus the integral of e to the x sine x. What do you notice about that final term? Where have we seen that term before? Hopefully on this screen. Exactly. And we said that the integral of e to the x sine x was I. So now we have that I is equal to e to the x sine x minus e to the x cos x plus, sorry, I messed my sign up. So plus and a minus means that should be a minus. I, 2i is e to the x. I'm going to put sine x minus cos x. So the integral value is a half times e to the x sine x. I don't know why I did that funny bracket. A half e to the x sine x minus cosine x.
I hope you enjoyed the video. If you did, be sure to click down here to like, subscribe and share with a friend. If you'd like to access the full online course, including the notes pages we were making, there's a link in our description below. Thank you for watching and good luck with your revision.